Hello all friends, this is your first program. If you know already, please watch the next video. So the pattern is, if you don't know what is the pattern, I'll just tell you. The pattern is, I'll tell you to pause the video, I'll count till 5 and you need to pause the video, and after that I will explain the concept here. Okay, so I'm going to count till 5, you pause the video and try to understand what is happening here. So 1, 2, 3, 4, 5. I think you would have paused your video by now and maybe you got the answer. So let's look at the answer now. At least compile error is not there. So let's go ahead and run this. So the answer is hi there 8, which is this one. Yeah, last one. Okay, so this is the answer for you. So we'll try to understand this, what is happening here. So we all know there are two function calling here. One is printf, another one is again the printf. So first this printf will be called and it would call this printf, okay? Because generally what happens, if you have written something like this, function, and inside that function some another function, let's suppose this one, okay, and you are calling this function, but before that this function will be called, okay? So the same thing is happening here. You're going to call printf, but before this printf this will be called, because this printf need some value which this printf will return, okay? So here also the same meaning is there. This function would return something which this function will get as a parameter. So compiler will go and see this function first and will try to call this function, but it won't be able to call just because its parameter is not fixed. So in order to get the parameter, you need to call this function 1 first, okay? So function 1 would get called first. So that is the same scenario here. So in that case, this printf will print this hi there. First it will return how many characters it printed, okay? So there are 8 characters. So the printf always return how many characters it printed successfully, okay? So that 8 will come here, and instead of this thing 8 will come like this and you will print that 8. So first what happened, you just printed this and it returned 8 like this, and that 8 is printed here. That's why this hi there 8 is there, okay? In order to show you, I'll just increment one more character here like this. So now it became 9. If I will compile this again, see this hi there 9, okay? This is how this printf work, okay? And this is what printf returns. If you want to see what scanf returns, check out the next video. Hi friends, this is another question. If you watch my first video, in that I have shown how this printf work. So first this print will be called and this printf will end up calling this scanf, okay? Because you need a data to print, okay? And data is supposed to come from this scanf. So first this scanf will be called here, okay? So I'm going to count till 5. You pause the video and try to understand that. 1, 2, 3, 4, 5. I think you would have come up with the answers. Let's go ahead and check that. So this is 2. Hit enter. At least compilation error is not there. Now hit and run this. So now printf was called and printf end up calling this scanf, and this scanf is waiting for me to give the input here. So I will just give some input like this one. Okay, this will go into P here. Now it is waiting for J input. I will give J input as 10. Hit enter. It is giving you 2 output. That means this C is the correct answer. So what is happening here? Scanf returns how many parameters it got successfully. So I gave 2 parameters here, Rupesh and 10. Okay, or you can say 2 elements, Rupesh and 10. So that's why it returned 2. That I read successfully 2 elements. That's why it returned 2, and this printf end up printing 2 here like this. Okay, remember this what I told. In order to make sure that this thing is really working the way I am telling you, I will just create another variable here. So we are looking for 3 values now here. Okay, so it should come 3, right? P, J and I. So again we will compile this, run this. Again I will say Rupesh. This time I will say my another name, Ethan. This time I will give some value like 20 and 30. See, this time it is giving you 3. That means it read 3 elements successfully. That's why it is returning 3. Who is returning 3? Scanf is returning 3 after reading all these 3 values. Okay, and printf is printing just 3, which is coming from scanf, like this. Okay, so I think we all know how this whole thing is working. So let's look at the next video now. Hi friends, this is your another question. This is very simple question, but if you know this, what is this constant thing is. Okay, so I'm going to count till 5. Pause the video. 1 2 3 4 5. So let's look at the answer for this. This is 4 compiled successfully, so at least compilation error is not there. Now we'll run this and the answer is main. So from where this main is coming? Actually this function is nothing but a constant. Okay, these are special constant available in our C and C++. Okay, so if you will write this and print it, or you will assign this value into somewhere else, then it will return you the characters. Okay, and there is not only this function. Actually this function means in what function you are. So currently you are in this main function. So if you want to see something like this, like you are in some another function and you want to print what is that, then you can just simply print this also. Okay, so if you will call it from here, now you will be able to see that it is giving you this function name. Okay, we will compile this and we will check that. See, first it printed main because it printed this one. Then you are calling this function. We are going here and we are printing again the same statement. Now this time this function is this function. Okay, this one. And from here if you will go to some another function, let's say some other function, then it will give you some another function name, like see some another function. And if you want to print here this one, it will give you some another function. So we can just compile that and see main function and some another function. And this is not done. We don't have only this function thing. We have lots of things like functions. Here instead of function you can just give file. Okay, then it will print what file name is, like 4.c. so we can check that also. Okay, I need to remove this. Compile, run. See 4.c, and this is the file name. Okay, not only this, we have something called date also. Okay, we can compile this, run. So it is telling you the date also. Okay, so answer to this question is main, first one. Okay, so I think we're done here. Let's look at the next question now. Hello friends, welcome to another video of this C MCQ series. I'll count till 5, pause the video and try to understand what is happening here. 1 2 3 4 5. I think you would have come up with the answers by now. So what is happening here? We are just simply doing the modulo operator on 5.3 modulo division with 5. So generally what we would expect is like this: 5.3 modulo 5 should be 0.3 here. Okay, so this is what we would expect. Okay, so let's see whether it is the expected thing or not. So this question is 5. We'll compile this, and it is a compile time error. We cannot apply modulo operator on floating point numbers. Okay, if this floating point is not there, this is going to work. See, we will compile this. There is a warning. It is saying that you are using this float, whether it is getting integer here. I will just remove this one so that it can be easy to see. Yeah, 0, that is expected. If you will do it like 7 here, we expect 2 as the answer. So 2 is coming as the answer. So that is okay. But if it comes to floating point numbers, then how to do that? So there is a function called fmode for that purpose. So I will make it as previous 5.3, and there is some function I told fmode. Okay, you need to pass these two values into that function and it will work. And yeah, you need to include some header file also, that is math.h. Okay, so we will compile this it is telling you D. Yeah, and this time this F mode returns floating point number. So in that situation we need to have this F here. Okay, so let's compile this. Oh, it is telling some F mode undefined. Yeah, we need to give the library explicitly. So minus LM. See, now it is compiled, and if you want to run this, your expected output would come. See, 0.3 is coming. Okay, so this is how we do floating point modulo operations. This function, we use this function. Okay, so we are done here. Let's look at the next video. Hello friends, this question is not compilable, but still I will give you the correct answer here. So first you try to understand what I am asking. The question is, what is the declaration in below code? So is this a declaration, or this one is declaration, this one is declaration, or this one is declaration? Just try to find these numbers like 1, 2 and 3. These three are declarations. Okay, so this is your answer for that. I'll count till 5. Pause the video and try to understand this one. 1, 2, 3, 4, 5. I think you would have come with the answer by now. So see, this first one is a declaration part. Whenever we write extern in front of any statement like this, here it could be float or anything. Okay, it means we are saying this is external to this file or this place. You won't get it here. Okay, and this is also a declaration. This is function declaration. Okay, and this is also a declaration. Actually, you don't need extern keyword to declare a function. But this is not a declaration because you are having these two curly braces. It means you have given the definition for this, even if you are writing this extern here. Okay, so answer is 1, 2 and 3, which is this last one. Okay, so let's move to the next video. Hello friends, this is your next question. I'll count till 5. Try to understand the question. 1, 2, 3, 4, 5. I think you would have got your answer by now. So let's compile and check the answer for this one. GCC 7.c. Okay, so there is a compile time error. So the answer is B1 here. Okay, so we'll try to understand why this compile time error is there. If you are writing that this I is extern, then you cannot initialize it. Okay, so the error is this only. I has both extern and the initializer. You cannot have this and this both. Either you can initialize it or you can tell it is extern. By means of writing this extern here, you are saying that I am just trying to declare I, and by this 10 initialization means you are telling that I will be defining this I. So at one time you are telling I'll be declaring only, and one time you are telling I'll be defining also. So that is the confusion. So if you will remove this extern from this place and we'll compile this again, it will compile successfully and it will run and it will give you the correct output. But the original answer for this is compile time error. Okay, so let's keep this extern here and let's look at the next question. Hey guys, this is your next question. So I'll count till 5. Try to understand this question. 1, 2, 3, 4, 5. Pause the video. I think you would have got your answer by now. So let's look at the solution for this one. So this is number 8. So at least compile time error is not there. We will run this and the answer is B97. So lots of people would have got this correct answer, which is this D. So if you got the answer, move to the next video. If you don't understand what is happening here, stick to this. So you are having this character, you assign a character to A here. Okay, now you are incrementing that with this increment operator. Okay, so if you don't know the way this post increment work, you might have missed the answer here. Okay, so here A means in ASCII it is 97, so you are assigning 97 into this X. Okay, and when you are coming out from this statement, I mean when you are coming at this line or this line, then you are incrementing this A. Okay, so in that situation you are incrementing whatever is there inside A. So inside A this is there, so you are incrementing from here to next. Okay, it means you are incrementing from 97 to 98. Okay, so in that situation you ended up printing B here. Okay, and here it is 97 only because this is post. Okay, this is post, that's why this addition will happen after initialization. Okay, so if I will make it pre like this one, then it will give you some another output, and we will see that what is the output. See, it is 98. It means it is incrementing it before and then it is initializing it. Okay, so that's why you are getting this X as 98 now. Before it was 97. Okay, it is pretty much clear here. And if you are confused with this one, it is nothing but the matter of this character pointer here. If I will print it 90, if I will give 97 here, it will print A only. Let's suppose it is like that. See, 97 is the ASCII value of A, and if you will print character and pass this 97, it is going to print A only. Okay, if you want B, you just make it 98. Okay, see B. And to clear your more doubt, I will give 98 here also. Okay, so it will be like 98 will come here because you are going to print the decimal value, and here you are going to convert this whatever the value is coming from here into the character. So character value of 98 is B only. Okay, that's why you're getting B here. If you don't know what I am talking about, all these things, just go and check the ASCII chart of your C. You will get what I'm telling. Okay, so let's look at the next video now. Hello friends, this is your next question. I'll count till 5, try to understand this. 1, 2, 3, 4, 5. And I think you would have got your answer by now. So let's check this. This is 9. At least compilation error is not there. Now you will run this and the answer is 1, 0. So this is the answer here. Okay. So if you know the answer, please move ahead and check the next video. If you don't know, stick to this. So what you are doing is you are initializing the data type, which is EMP. Okay. So you have this EMP and its data type is consisting of these 3 data type: age, cell, and integer. I mean integer float and integer pointer here. Okay, so if you will give it like this, the first element will get assigned here. Okay, so this age is getting this 1 and rest of the members are not getting anything. Okay, that's why if you will print this salary, this is 0. Okay, and I'm not printing the third one because it might create a dangling pointer problem. Okay, that is not good idea to print null pointer here. Okay, so in order to understand it well, you can just assume these 3. So this time it will be 1 and 3. See, 1 and 3. Okay, so it's very simple code. So I think everyone will understand this. So let's move to the next question now. Hello friends, look at this code. It is a little bit weird code because I have given this here before even this td.h. Is it perfect code? Is it going to compile? You have to think about that. So 1, 2, 3, 4, 5. And I think you would have come up with your answer. Check out the answer now. This is 10, right? So 1, 0, 10. At least compilation error is not there. And oh my god, there is no error in this code. And yes, there is no error because the compiler works on tokenization and it gets token here and there or here. It doesn't matter. You are going to use this Rupesh, and before that you have given the definition for that. So it is pretty much okay. So even if you write it here or here, doesn't really matter. Okay, we'll compile this one and get the same output here. Okay, so if you get something like that in some MCQ question, just hit yes, it is possible. So now let's look at the next question. Hello friends, this is your next question. Try to understand. I'll count till 5. 1, 2, 3, 4, 5, and you just pause the video. Yeah. And I think you would have come up with the answer by now. So let's look at the solution for this one. So this is your 11. So this is just a simple warning here. And if you run, oh my god, this is perfect code. Okay. So this my function called is the output here. Got it? But this is not a valid situation for C++. It is C, that's why it is working. If it is C++, it is going to give you an error. This is a warning. It is telling you that it is implicit declaration, but that is okay. You can get away with this. Okay, and you can just run and check that it is perfectly fine. But if I will compile this code with C++ compiler, it is going to give me the error. It is going to tell you that, okay, the first error is you need to return an integer, and the second error is my function was not declared in this scope. Okay, so I will remove this first error with this integer here, because C++ always look for that. So if I will compile this with this C++ compiler, you are going to get error. This code is not compiling at all, and it is telling you that I am going to call this my function here, and till now I have not get the definition for this. Okay, even a declaration for this. Okay, so Control X, paste it here. Now this code is fine. If you will compile with C++, it will compile with no problem and run with no problem at all. Okay, so maybe you don't know what is C++, or you know, so I just wanted to tell this point here. Okay, so we are done. It is possible in your C to call some function even if it is not declared before this. Okay, so let's look at the next question now. Hello friends, so this is your new question. Try to understand this question. I will count till 5 and pause the video and try to understand this question. 1, 2, 3, 4, 5. So I think you would have come up with the answer by now. Let's look at the answer. Answer is 1. Okay, so compilation error is not there. It is 1. And why it is 1, I will explain. If you know answer, check out next video. And if you don't know, stick to this. So this small is less than big. So first of all, I will just remove the confusion from here. This is 1 and this is 2 and this is 3. So if something like this is there, I'll just compile and show whether it is working or not. Yeah, it is working. So this 1, 2, 3 is there. Now how compiler is compiling this whole thing? Compiler is doing like this. 1 is less than 2. Yes, it is true. It will return true, and true is nothing but 1 here. Okay, is this true? 1 is less than 3. Yes, it is true. Compiler will again return 1 here, and that 1 is getting initialized here, and you are printing, you are getting that yes. Okay, so this 1 less than 2 less than 3. Okay, let's suppose it is like this. So what is the answer? Can you guess it? I know you can guess it. If you got correct output by the end, you can comment out. Okay, so 1 less than 2, this will always return 1 here. 1 is greater than 3. No, it is not. Then 0 will get returned. So whenever you compare something, there is some conditional or some comparison operator is there, or something like this is there, like if 1 is equal to 1. Okay, or I will write like 0 is equal to 0. Yes, it is true. So once this condition is checked, compiler returns either 1 or 0. Okay, so in this situation 1 will come here. Okay, and 1 is means true. You can go inside this if condition here. Okay, if it is 0, you are not allowed. Okay, so if it is like this, 0 is equal to 1, no, it is false. In case of false, 0 will get returned here. Okay, and if it is 0, you cannot come inside. Okay, the same is applicable to loops also. Like if you have while loop here, and if you have 1 is equal to 1, then in that case it is always 1, means it is always true. So this will get compiled and 1 will come here. Okay, and 1 means true. I already told 1 means true here. So I'll just simply write also true is equal to 1 and false is equal to 0. Okay, so if it is true, 1 will come here. If it is false, like if it is this 1 is equal to 0, no, it is not. So in that situation, false will come here, and false means 0. Okay, so we will check that what I was writing here before, it was 1 less than 2 greater than 3. Okay, so once we'll compile this, we'll get this 0. Okay, why? Because 1 less than 2, yes, it is true. In true case, it will return 1 here. 1 is greater than 3, no, it is not. So in that situation, 0 will come here, and 0 is getting assigned to this k, and we are just printing that k here. Okay, I think it is clear. If you have any doubt, please comment out. I'll be very happy to answer that. Hello friends, welcome back to another question. I'm just going to count till 5 and you're supposed to pause the video and try to understand this. 1, 2, 3, 4, 5. I think you would have come up with the answers or the questions, but still, let's go and compile this. So this is GCC 13, okay, compile. So at least compile time error is not there, okay. There would have been a warning if you are not keeping this, okay. So I will just show you that. If we are compiling, there is just a warning here, okay. It is telling that there is an implicit declaration of this function here, okay. And whenever there is an implicit declaration, it means your compiler is calling this one but still doesn't know where is this, okay, because there is no declaration for that. I mean, what parameters it takes and what parameter it returns and all that. So it assumes, and it assumes means it will assume only one thing, that it will return an integer and will assign into that, okay. So this is a basic assumption that it will do. So let's go and compile this. This is GCC 13.c. At least compile time error is not there now. And now this 502 and 4, 502 and 4, this is the answer. And if you know already the answer, you can move to the next question, otherwise stick to this video. So what is happening here? We are creating an integer a. We are assigning that integer a with this value. 502 is coming here. Everything is pretty fine. It is printing 502 with this new line character here, okay. So if you have attended my previous videos, then I showed you that printf always return how many characters it printed successfully. Like if you are giving 1 2 3 4, which is 4 character, then if you will print what is this one, I mean what is the output of this one, you will get, how much you will get, you just guess that. I'm going to tell you that, okay. So we'll compile this and run this. 1 2 3 4, and this is giving 5 as output. It is creating lots of confusion, right? So I will just remove all these. Compile, check. It is giving 1 2 3 4, that is okay. 1 2 3 4 is coming, but this printf is returning how many characters it printed. So it printed 1 2 3 4 and this new line character, okay. So in that case it became 5, 1 2 3 4, and this one including 5. So it is returning 5 to this one and it is printing 5. So first it is printing 1 2 3 4, after that it is printing 5. See here, 1 2 3 4, and this new line is coming. So new line is doing its job, but still printf always return how many characters it printed successfully. So it printed 1 2 3 4 and this character also, okay. So in that case it is giving you 5. So similar thing is happening here also. You are coming, 502 is coming here, 502 is getting printed here, and one new line character is also printing, which is resulting into 4 getting returned from here, and you are printing that 4 here, okay. So that's why it is 502 and 4. This is the answer. So let's move to the next question, and if you have any doubt, please comment. Hello friends, this is another question, and this is just a for loop, okay. I can give you a hint, this is not a compile time error, okay. So I'll count till 5, pause the video and try to understand this. 1 2 3 4 5. I think you would have come up with the answers or the questions. Let's go and compile this. We compiled it successfully. I told you there is no compilation error, okay. Now we will run this, enter. And what is this? If I is equal to 5, so I will give 5 as input, enter. So the answer is 5 4 3 2 1. So this is the answer. And if you know how it is functioning, move to the next video, otherwise stick to this video. I give 5 here. Now 5 was written something like this, and as it is non-zero value, we will go inside loop, and there is no body because I have given this semicolon here. It means this is a single statement. It will execute itself again, okay. So this time it will go here. I told you once loop is done, it comes to third position. So this time it will come here and it will try to print whatever the value of I is, and I will get simultaneously decremented. Now this time as I was written here, now this time as I was decremented, I will get 4 here. 4 is also a true value. You will again go and print 4 and I will get decremented by 1. So this time 3 will come. Again 3 is a non-zero value. It will go get printed and it will become 2 now. So like that it will print up to 1. One time this will get 1. It will go here. It will get decremented by 1, which means I will become 0. But before getting 0, as it is post increment, it will print that. So 1 will get printed here and then 0 will come here. Okay, because I has changed it. So 0 will come here. Now you are going to terminate that. That's why this loop is going from 5 to 1, not 5 to 0. Okay, so let's look at the next question now. And yeah, please, if you have any doubt, comment out. Hi guys, this is your another question. This is just one line question, but still lots of people don't know whether it will compile or not. So I'll count till 5. Try to think about it. 1, 2, 3, 4, 5. So GCC 22. It is compiling successfully and the answer is this one. Hi, this is Rupesh. Okay, so from here to here. If I will give something little bit cleaner code, then it will be very easier to see this. Yes, hi, this is Rupesh. So what you understood from this, there is no difference between writing it like this or writing it something like this. You just remove this all. There is no difference in between these two. Okay, today you learn lots of things, right? So if you want to learn more, go to the next video. Hello friends, so this is a very silly question, I know this. Okay, so just try to find the answer for this and we'll quickly move to the next video. Okay, 1, 2, 3, 4, 5. I think you will have come up with the answer and I know the answer is 100. Okay, so let's compile this code and run this. Answer is 100. Why? Because there is a structure, its name is book. You created the object of that structure and this b.pages you are assigning 100 and you are just printing that 100. Okay, so there is no fancy thing or no error or no need to dig into this much because it is really very simple question. So let's move to the next question. Hello friends, this is your next question. I'll count till 5. 1, 2, 3, 4, 5. So let's go and check the answer now. If it is like this, oh, there is a compile time error. Okay, this break cannot come without loop, okay, or without switch statement. So there are two positions, two things where this break can come: inside while loop, inside while loop, here break can come, and if you have some switch statement, then inside that it comes. Okay, like case 1 here and break. Okay, you would have seen all these things in your C book. Okay, these things. So break will either come in between switches or in while loop or for loop or do while loop. Okay, so it comes either in loops or in switches, but doesn't comes in raw if condition. Actually it can come inside if, but that if should be in loop then. Okay, so at least if you will go upper in the hierarchy, this break should at least meet a simple loop, at least a loop or at least a switch. Okay, so that's the situation here. I'll just explain what I'm telling you here. This is perfect code if this is inside any loop like 1, and if this is like this. Okay, if this is like this is perfect code because this break is now not inside this if. Actually it is inside if, but if you will go up in the hierarchy, then you will at least meet one loop, okay, which is this while loop. So this is a perfect code. Now we can compile. There is no error in this and it will give you an infinite, no infinite, because this is break, so once it will come inside. Yeah, so the answer is success then. Okay, so this break should not be without loop and switch cases. Okay, so let's move to the next video now. Hello guys, this is little bit interesting question because it has so many semicolon. Let me put furthermore these many semicolons. So what do you think? What should be the output for this one? So I'll count till 5. You go and search in the internet or whatever you want to do. Come up with the right answer. 1, 2, 3, 4, 5. I think you would have got your answers by now. So let's go ahead and check this. This is 18. Yeah, at least compile time error is not there. Okay, so this is a perfect code. Actually, it's not a perfect code. You should not keep these things, but still, it is acceptable. Okay, and if you will run this, what am I doing, man? Hi, there is the answer. Okay, so C is the answer here. And let me tell you, even this is also a perfect code. Okay, if you will compile, it will get compiled easily, C, and if you will run it, again the answer is hi there. Because these all are empty statements. There is no statement written before this semicolon. So this semicolon will go off when the pre-processing state, not the pre-processing, when the compilation is happening, there is this empty statement, and compiler is very much smart. It will remove the empty statements. Okay, exactly the way it removes these white spaces. If you will give these many white spaces, still your program will compile, right? We all know that. Okay, see, so this is also exactly like that. Okay, so this is no error code, it just print hi there. Let's move to the next video now. Hello guys, welcome to this question now. Try to understand what is happening here. I have given similar examples before also, but there is a difference here, because before we were using something like this, like %d and comma, and let's suppose 5 6. Okay, so this is little different here. So try to understand for this one. I'll count till 5, pause the video and try to find the answer for this one. 1 2 3 4 5. I think you would have come up with the answers, so let's go ahead and check that. This question is 19, so 19.c. At least compile time error is not there. We all know compile time error will not be there, and the answer is ₹6. This one, C is the answer here. And why? Try to remember guys, I told you printf return how many characters it printed successfully. Okay, so in case of that, what we were studying before, like 1 2 3, so this is going to print 1 2 3, and it is printed 3 character. So this whole printf will return 3, and this printf will print 3. Okay, so we can compile this, we can run this. See, 1 2 3, this 1 2 3 was printed with this printf, and it returned 3, and that 3 was printed here. If you will give new line character here, it will return 4. We can compile and check that. See, 1 2 3 was printed, and just because of this new line character, this whole thing became 4 characters. Okay, because 1 2 3 is there, and this one extra character is also there, so it becomes 4. That's why it is returning 4, and you are printing here 4. Okay, so I wanted to show that it doesn't only work in case of like printing integer, float and all that. No, it doesn't work in that situation. It works with strings also. Okay, so I think I made my point here. Let's move to the next video. Hello friends, welcome to this MCQ question, and this is a little bit tricky question. You need to be very much strong in character pointer and integer and how the data are stored in the RAM and all that. Okay, so if you don't know, I'll explain you that. Okay, so just don't worry about that. I'll count till 5. You try to understand this. I'll just count till 5. You pause the video, try to understand what is happening in here. Okay, 1 2 3 4 5. So let's look at the answer for this now. GCC, this question is 21. At least compile time error is not there, and the answer is 10,000. So C is the answer here. Why it is like this, I'm going to tell you that. Okay, so what we are doing here is we are creating an integer variable which is holding 10. Okay, so the memory layout would look like this. I am prepared for you guys. So the memory would look like this. For A, the memory is supposed to look like this. We all know it is supposed to have 4 bytes. Okay, integer is a 4 byte. Generally, if it is 32-bit system, then this is going to look like this. Okay, in first byte you will store this 10. Rest of the byte will have nothing in that. And yes, my system is a big Indian. Okay, big Indian. I don't know the spelling here. Maybe this is this one. Okay, so big Indian means the bytes would be stored from left to right, otherwise it will be stored from right to left. Okay, so mine is big Indian, so it is stored from left to right. So this is 10. 10 is nothing but just 1010. In that case, we will write this whole thing in first. Okay, so this is how we do. If you will print this one, this is 10 only. Okay, and rest of the bytes are 0. That's why you are getting 10 in first loop, 0 0 0 in rest of the loop. Because when you typecast some address into some another address and read from that pointer, compiler read that many byte only what is the type of your variable is. Okay, so here PTR is of type character, so character size is 1 byte all the time, so that's why it is reading 1 byte all the time. So this PTR is nothing but this initially holding this first address, and this A is also initially holding this first address. Now you have typecasted this address into the PTR. Now if both are pointing at this location, and if you will print A is of 4 byte, so this whole thing will get printed all together. Okay, but if you will print PTR, it will only print 1 byte. So wherever the PTR is pointing, initially it is pointing here, so 1 byte means these 4 bits, so it will print 10 first. After that you are incrementing this PTR, so this PTR is getting incremented by 1 byte, which is this whole thing. So this time PTR is coming here, so it is pointing to this location now, and you will end up printing PTR which is of 8 bit, so it will print 0 here. Then again you are doing the increment, it is again jumping from here to here, and you are getting again 0, and here again 0. So the answer is 10 0 0 0. Okay, I think I made my point. If you guys don't know what is Little Indian and Big Indian, I'll be uploading videos on that, so go and check out my other playlists. You will definitely get this, what is Big Indian and Little Indian. For now, let's look at the next question. Hey guys, this is really very interesting question. I bet you would have not seen something like this before. Okay, so try to understand what is happening here. I'll count till 5, pause the video and try to find the answer for this. Okay, 1 2 3 4 5. I think you would have come up with the answers by now. So let's go and compile this. This is GCC 23. At least compile time error is not there. So the answer is this one, C. Why it is like this? The first 20 tells that I want 20 slot. Okay, so this whole slot is 20. Next thing tells that I will be taking only 9 characters from this string. Okay, and will push into this 20 slot. Okay, so if you will take only 9, then it will come up to here only, like this one. DA will not come. Okay, from here to here it is 9 characters. So after taking that, it is pushing into this 20 slot. Okay, so that's why the answer is this one. And if you will count from here, it is like 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. Okay, so this whole slot is 20, and you are telling I'll be taking only 9 characters from this string, which is this one, and I'll push into this 20. Okay, so that's why it is giving you this answer. And let's suppose if this is 20, then what do you think? What should be the answer here? No. First I will not give this 20. First I will give 13 here. No, 9, 10, 11, 12. So I will give 12 here. So what do you think? What should be the answer here? It is telling I will be taking 12 characters from this string, and this is total 12 character. Okay, this string is of total 12 character. Rupesh Yadav. So let's try to compile that and get the answer here. So it is printing whole thing. So as I said, 20 slot is there. You are telling I'll be reading 12 characters from this string, so which is nothing but the whole string, and I'll push that into this 20. So after reading Rupesh Yadav, you just pushed it. Okay, and you are always pushing from the back side. Just try to understand it like this. And let's suppose if it is 20, then what do you think? What should be the answer for this? Is this Rupesh Yadav is going to start from here, from the beginning, or what? So I will compile for you this. Let's go and compile this and run this. So actually there is no difference. Why? Because you are telling I'll be reading 20 characters from here, but there is only 12 characters. So you read only 12 characters and you push into this slot, which is of 20. Okay, so that's it. if you encounter something like this in future, you'll be very much confident about your answers. Okay, so let's move to the next video now. I hope you enjoyed it. Hello friends, this is your another question. Try to find the answers with the help of pen and paper and all that, okay? Or you can just go ahead and compile this and check the answer and try to find the exact reason why it is happening. Okay, so what I'm doing here is I'm assigning this minus 12 into this integer, which is assigned integer, and after that I'm shifting it 3 times in right. Okay, and I'm again assigning that shifted value to this a and just simply printing that. Okay, so try to come up with the answer. I'll count till 5. Pause the video. 1 2 3 4 5. I think you would have come up with the answers by now. So answer would be 24, right? Yes. Answer is minus 2. Why it is minus 2? We will see that. So I am prepared for you. See, this 12 is nothing but this. Okay? Or if I will remove this for simplification, it will be really very good. Because you guys might get confused why I am writing it. Only 2 bytes. Okay? So if you will consider that in 1 byte only, then this 12 look like this. Okay? And minus version of 12 is look like this. Because this is 2's complement of that, and we all know how to create 2's complement. Okay? So this is the minus 12, and if you don't know how to count 2's complement, I'll tell you that. You just start looking from the right side, and once you encountered the first one, you keep the value as it is, and after that one you just flip the values. Okay, so you will notice this 001 is exactly same here, and after that everything is just flipped. Okay, 1 became 0, 0 became 1. So this is the 2's complement, and this represent minus 12. Okay, so this is 12 and this is minus 12, and after doing this minus 12, I am shifting it 3 times. So if you will shift these 3 times, this will be the answer. Okay, and I should remove this also. Okay, so this is after shifting, and this is the value. So this 100 will go off. Okay, and this 01111 will come here. So 0111 and 1 comes here, and as it is negative, ones will get appended. Okay, from left side. So this is nothing but minus 2. Okay, so we're done here. If you have any doubt, please comment. I'll be very happy to explain that. So for now, let's look at the next video. Hello friends, this is another C MCQ question, and this will clear your one very beautiful doubt about size of an strlen. Okay, so let's look at this. We will just print what are the return value of these two. Okay, and try to find the answers. I'll just pause the video, try to understand this. 1 2 3 4 5. So I think you would have paused your videos. Now tell me the answer. For that, I will compile this GCC, and the question is 25. Let's compile. At least compile time error is not there because there is no compile time error. I know that. And the answer for this is 7 and 6. I know lots of people would have given the correct answer for this, but still I know few people are there who don't know what is the difference between these two. So size of is a operator here. Okay, this is not a function. This is a compile time thing. Okay, it doesn't get executed like you are passing something in some function. No, this is not a function. This is an operator. Okay, like this plus, minus, and all these operators are there. This size of is also an operator. So if you created this Rupesh, this is a constant string. We all know that. Okay, now size of will return this whole string size, means the characters. So there are only 6 characters plus the null which is appended in the end. Okay, and there is always a null in the end. That's why whenever you print something like this, it doesn't keep on printing whole thing even after this H, because the thing generally look like this, Rupesh, and this 0 is also there. So printf will read first R, print to the console, U, print to the console, P, print to the console. Till h it will print to the console, and when it will hit the null here, which I am representing with 0, it will terminate printing. Okay, otherwise this is stored in some memory, and this memory is nothing but the RAM, and that is infinite. So there is no way to stop that. So it will keep on printing. No. So in order to stop that happening, we generally append one extra byte in the end of the string, which is called null, and which is a terminator. Okay, so size of gives you the size, whatever the size of your character string is there, plus the null also. That's why it is printing 7. Okay, you saw that. And this strlen is just a function, and it counts how many actual characters are there in your character. That's why it is returning 6 here. Okay, strlen we printed, it is giving you 6. So I think we are clear here. If you have any doubt, please ask in the comment section. Let's move to the next question now.
Hello there, this is Rupesh and you're watching CPP Nerds video series on MCQ question, and in this question we will be learning about how to create a pointer in one function and create the memory in another function. Okay, so generally we see like we are creating a pointer, and along with that we create the memory like this. Okay, but in this case we are passing this pointer here and creating memory. Okay, and assigning the value, and at last we are printing it. So let's see what is the output of this one. Okay, so before going that, you try to understand the question. Okay, I think you would have got your answers. So let's compile this code. It is not working. See, there is a runtime error, and this is a segmentation fault. Okay, so A and D both are the answer, so don't blame me for that. Actually, the precise answer would be a segmentation fault. Okay, and why it is like that, let's try to understand. So let's quickly write the memory models for these. Okay, so this is integer pointer, so this is your P, and let's suppose 0 cross 21 is the address of P. Okay, and the type is integer pointer. So initially it is holding some garbage number, let's call that G. Okay, so this is some garbage address because we have created that. After that we initialize null. Okay, so let's write null here. Okay, now you're calling this function and passing P, and passing P means passing null, not the address. Okay, so if you write it like integer I is equal to 10, and you pass this I into some function, let's call that function I, then you pass 10. Okay, not the address of I. So here also you will pass null, what this pointer is holding. Okay, so null will go here. This is your another P. Okay, and let's call the address of this P is 0 cross 22, and null has come here, and this is also this P. Now what you are doing, you are creating a memory of size integer and initializing that into P. So this would look like this, 0 cross 22, and that memory what you created, let's assume this is your heap, and we know that malloc get the memory area from heap, and let's suppose this is your memory, and let's assume the address of the first byte of the memory is 0 cross F and F. Okay, and this is your new P. Okay, after this statement, now this statement is you are using this star mark. It means you are dereferencing this 0 cross FF and initializing 10. Okay, so you have successfully initialized 10 here. The first byte is 0 cross FF. Okay, and this is size of integer, so there will be 4 bytes, 2, 3, 4. Okay, and 10 is assigned to all those 4 bytes. Now you are done with this function. You have assigned 10 here. Now you are coming back. After printing this, this P is different than this P. Okay, this P is still holding null. Okay, and now what you are trying to do is you are dereferencing null, so you are getting the segmentation fault. Okay, So that's the reason you got this segmentation fault and it stopped running at runtime. So what do you think? What should be the solution for this one? Actually, the solution is we will not send P. Okay, we will send the address of P. I'll show you that. So before we were sending P, this time we'll send the address of P, and few modifications would be like this. And here pointer, here double pointer. Okay, so if you'll compile this now, see the answer is 10. So what we have achieved what we wanted. But how is this working, like address and all that? So let's understand this one now. So let's quickly write this again. This is P 0 cross 21. Here it is null. Okay, and you're passing the address of P, okay, which is this one. Okay, so you will get address of P, and we will create double pointer because you are holding the address of the pointer. Okay, so this is pointer, you're sending the address of the pointer, so in that case you have to catch that into double pointer. Okay, before you were sending pointer itself, so you was getting it into one pointer. Okay, so we will create that 0 cross 21, and this time no, this should be 22, and 21 is coming here, 0 cross 21. Okay, now we are creating the memory for this one and dereferencing P. P is this one. Okay, this is your P, so we are dereferencing this memory address and initializing whatever the address we got after this malloc to this area. Okay, to this area means here, and as I said, there is this heap, and from somewhere here you are getting 0 cross FF, then this 0 cross FF would come here. Okay, this is your heap. Now what we are doing here, this is double pointer, so it means we are dereferencing 2 times. Why we are dereferencing 2 times? Let's understand that. P is this one, so let's write this. Okay, so you are dereferencing address 21, means you want the value part of this address. Value part is this one, so the result of this is 0 cross FF. Okay, now again you are having this one pointer, so this another pointer is this one. Okay, so you are again dereferencing this one. It means you are referring to this memory location. Now you are sending 10 to that memory location, then your 10 will come here. Okay, so that's how this whole thing is working, and it is really very simple if you know the pointer concepts. Okay, but we are not finished yet. This function is going to get completed. We'll come back here, and then we are dereferencing P here. Okay, P star. So I told you P is your 0 cross FF, so if you will dereference this, you will directly get this value. Okay, that's why if you are comparing this, you are getting 10 as the answer. Okay, that's how we achieve this. So thanks for watching. Bye bye.
Hello friends, I'm here with another interesting C MCQ question. See what is happening here. I have this printf which is printing this var variable. This var variable is declared as extern here, and its definition is given here. Okay, so this is just kind of declaration, and the definition comes from here. And first you are doing something, after that you are assigning, and you do something. So I won't tell you the exact answer. For that you just pause the video. I'll count till 5. 1, 2, 3, 4, 5. I think you would have come up with the answers by now. So let's go and check what is the answer here. It is 27.c. At least compile time error is not there, mind that. And the answer is 23 and 2. Okay, so what is happening here exactly? It is printing var. Okay, var is not there till now, but its definition is here. Okay, so it will search where is the var. Externally it won't look here first. Okay, it will check 23 and it will print. Okay, I told you it looks for the hierarchy up in the hierarchy. If this 2 is written here, it will take 2 from here only. Okay, but I'll just show you that 2 2. Okay, but this is not like that. It is here. So VAR want to get printed, but till now we don't know what is VAR. So we will look up in the hierarchy. Up means like this, and it will go up, and the global scope is this whole scope and this whole scope. Okay, so here it found 23 actually. Okay, or you can understand it like this also. There is something like this. Just remove everything like this. That external and all that thing was just to make you confused only. And forget about the scoping and all, because maybe you are fresher, so you won't be able to understand that much. So leave that. Just understand this now. VAR is 23, and first when you will print that, it will get printed 23 only. After that you are printing it here, and before that you have changed the value, so it will print 2 only. Okay, now it is very simple, right? Yeah. And then external and everything was just to confuse you, because this is what all about. This is what people do in MCQ. Okay, so just don't blame me for that. I'm just preparing you. Don't get angry on me. So let's look at the next question. So this is another interesting question. If you have watched my previous video, you know what is the precedence of evaluating commas in between these round brackets. Okay, so I think you know the answer, or maybe you don't. So let's go and check that. At least compile time error is not there, and the answer is 1. Why it is 1? Can you tell me that? Because this is 1. If it is 2 here, the answer is going to be 2 here. So we know the answer for this, right? If it is 10 here, it is going to be 10 here. Okay, so we will break this whole thing into pieces. Okay, so when compiler is going to assign I, it is coming to this scope first, full whole scope, and it is thinking I'm supposed to initialize this whole, but this is nothing but the expression here. So we need to solve this expression. So there are 2 separate expressions and separated with this comma here. Okay, so this is first expression. Okay, so this one will get evaluated first. So this is again internally 2 different expressions. So this is one expression and this is another expression. So here it will be 5, here it is 3. So first 5 will get evaluated, then 3 will get evaluated, then this whole expression is done. Okay, so just forget about this, just remove this. Now you are left with I is equal to 10. So when you will initialize this 10 into this I, what is there? It is nothing but 10 here, because you are going to initialize that I into again the same I here. Okay, that's why it is printing 10 here. I think you got the reason for that. Okay, so let's move to the next question, dude. Hi there, I'm back with another C MCQ question, and this is also again a tricky one. So I'll count till 5, pause the video and try to understand what is happening here and come up with the answer at least now. Okay, so 1, 2, 3, 4, 5. I think you would have paused your video and maybe you got the answer this time. So compile this. There is no compile time error. I don't know why I'm keeping this runtime error and compile time error all the time here. There is no use of this, right? You guys might be thinking like that, but no. In later point of time, maybe you will encounter subcompile time error. Okay, you cannot be sure about that. So the answer is 10 and 3. Voila, 10 and 3. This one. Okay, why it is like that? Why? Because I already told you that if you are evaluating comma based operations inside this round bracket, the precedence or the order changes. Okay, now the order would be first this expression will get evaluated, after that this expression will get evaluated. So in order to evaluate this expression first, you have to evaluate this expression first, because there is another comma in between these 2 expressions. Okay, so this is whole expression, and again inside this expression there are 2 more expressions. So this is one expression and this is another expression. So we all know if we are in round bracket, then we start from left to right. So in order to solve this whole expression, we need to solve first this tiny little expression, which is I is equal to 10. So I is initialized with 10 now. After initialization, you will print this I. So that's why we are getting this 10 here. Okay, so once you are done with this printing, you are done with this whole expression, this one. Okay, after that you are left with this I is equal to 3 here, which will execute, and you will come out from here just by assigning this I is equal to 3 here. Okay, and you're printing that I is equal to 3 here, so that's why it is 3 here. Okay, I think we got the reason for that. I hope you would have solved this question, because I'm taking this kind of example again and again just to brush up your mind, and I'm trying to just dig so much deep into this whole ordering thing. Okay, so that next time whenever you encounter something like this, you will be damn sure about the answer. Okay, so let's look at the next question now. Hello friends, this is another question, and this time I'll be showing you how this format specifier works. Okay, so this is an integer initialized with 30, and I'm printing this a, which is of integer type for different specifiers. Okay, I'm not using %d all the time. Okay, so this you need to know how to handle this kind of things. So I'll count till 5, pause the video and try to understand this. 1 2 3 4 5. 1 2 3 4 5. So I think you would have come up with the answers by now. So let's compile this. This one is 30, right? So there you got a compile time warning here. It is just a warning. Okay, so actually this is really an important warning. That's why it is coming at F only. Okay, not at this one, this one, and this one. Okay, so we'll see why it is. And for now, you just check the answer here. So the answer is 1E, 36, 30, and 0. This one. Okay, not this one. Why? Because we all know that. So if you will give this 30 to this hexa here, this is for hexa, this is for octal, this is for decimal, and this is for floating points. Okay, so if you will give this 30 to hexa, it will convert 30 into the hexa and it will print that. Okay, so the 30 is 1E. Then again 30, if you will go to octal, it will convert into octal, which is 36, and this is 30, and decimal is again a 30, so it is 30. But if you will give 30, which is an integer, to the floating point, it will always return 0. Okay, doesn't matter what you are passing here. Okay, if it is F and you are passing, let's suppose 80, it is again going to print 0 only. Okay, see, this is that 0 and this is this 0. Okay, so compile, run, see, and this is your previous error and this is again 0. Okay, no matter what you pass. But if you want to see this as 80, you just pass it like floating point, it will work. See, this is 80 now. Okay, so in case of floatings only, it doesn't work. That's why you are always getting this compile time error for floating points only, because others are internally typecasted and converted, but this is a problem. That's why you was getting this warning at compile time. Okay, so just don't avoid warnings when you are writing code for your companies or your projects, just because they just don't come for namesake. Okay, they have the significance, that's why they are coming. Okay, so I think you got the point here. Let's move to the next question now. Hello friends, this is a stupid question, but still you will get these kind of questions in MCQ exams. Okay, so that's why I have included this. So pause the video, I'll count till 5. 1 2 3 4 5. I think you would have come up with the answers, and we generally, everyone would have come up with the correct answer, but not those people who are really freshers. Okay, so for freshers there is an exception. You cannot initialize anything to this constant here. Okay, you can always initialize constant, I mean these literals, to the variables, but you cannot initialize these literals. Okay, even if not allowed this one, I mean you cannot simply assign anything to literal. You cannot change the value of 5 by saying like this. You can only change the variable. Okay, you cannot change 5 here because 5 is universally 5. So it's like that, you are going to change 5 here, which is not allowed. That's why it is not allowed. That's why this is a compile time error. Okay, so we are done here. Let's look at the next question now. If you have any doubt, please ask. Hi Fox, I'll count till 5, pause the video and try to understand what is happening here. 1 2 3 4 5. I think you would have come up with the answers by now. So let's check this. Why to run this one? Yeah, at least no compile time error. And the answer is not 0. This one, not this one. First of all, lots of people think it is equal to 0, but it is initialization. You are initializing it with the 0. Okay, so lots of people miss that because we generally think it is double. Okay, because our eye and our mind work in that direction. We don't see things so much properly. Okay, so this is one thing. Another thing, you are initializing it with 0. Okay, so after initialization, what remains here is x value, which is 0. So if it is 0 here, it is never going to come inside this. In order to come inside this, it should be a non-zero value. Okay, so it is printing not 0. If you are not sure what I am telling, you can initialize it with 1. If you are initializing it with 1, the remaining thing is 1 here, because you are remain with the x value, and x is nothing but 1 here. Okay, so we will compile this code and we'll check. Answer is 0. So this time it is getting inside this. Even if you will initialize it with -1 or minus value or whatever value except 0, it will always go inside this. Okay, 0. That means if considers all the value true except 0. Okay, so if this is like this, it is not going to enter in your this part. Okay, it is always going to go to the else part here. Okay, if it is like this value, anything except 0, it is true and it is going to get into this 0. Okay, so try to remember this from this example. 0 is always false. Apart from this 0, everything is true. Okay, so this was the motive to create this question. Okay, let's move to the next question now. Have any doubt, please ask. Hi once again, and this is another question. I'll count till 5, pause the video and try to understand this. 1, 2, 3, 4, 5. I think you would have come up with the answers by now, but before compiling, I will explain something about this. Okay, I wanted to show you the use of this one. Okay, this is used to tell to the compiler that next line, the very next line to this line, this whole line is also in continuation. Okay, so if you are writing it like this or writing it like this, both are equal. You had some issue, that's why you start writing the rest of the thing from next line. So if you want to do like that, you have to use this slash here. Okay, so we'll compile this code and see what is the result of this. Compiled successfully, and the answer is I love you, I hate you. Thanks for watching. Let's look at the next question now. Hi friends, just try to understand this. I'll count till 5, pause the video. 1, 2, 3, 4, 5. I think you would have come up with the answers. If you know what is this hash doing here, then only you can understand what is the output for this one. Okay, so let's go ahead and compile this. This is 34. It compiled successfully. If you will run this, it is going to give you this output, which is nothing but D. Okay, so D is the correct output here. Compile will reach here, will see. Okay, so before compilation there is a preprocessor stage. Okay, so preprocessor do nothing, just remove the comments. It will remove this from the program. It will search for any token which is looking like this. Okay, so function is some name. This is just kind of pattern matching. Okay, so this pattern is matching here. Whatever is this is function. Inside this bracket, this whole thing is considered as single x, this x. Okay, and this whole thing would get replaced with this hash x. So the significance of hash is whatever the value is coming inside x, I will enclose it with the brackets, sorry, inverted commas. Okay, so at last it is doing something like this. Sorry, it is just keeping this one here and enclosing with this bracket, sorry, this inverted commas. Okay, so this is the use of this hash here. Let's look at the next question. Hello guys, here is another interesting question. Pause the video and try to understand this question. I'll count till 5. 1, 2, 3, 4, 5. So let's check the answer for this now. We'll compile this. There is no compile time error, and the answer is 0 and 8. Okay, so 0 and 8 is the answer. So yeah, actually I'm keeping this space in between these two, right? So why 0 and 8? You guys might be thinking that something else might come, like 0 and 8 will come, sorry 9 will come, but it is 0 and 8 because you are going to initialize this whole expression into this x. First look is that. But if you will see inside this expression, there are two conditions here. I mean, there is one condition here and one increment is there, and there is this AND operator is there. Okay. So what happens if it is AND operator? It means it will evaluate this, and if it is true, it will evaluate this. So first it will go and evaluate this one. So 0 is equal to 1? No, this is not true. So once this is not true, it will give 0 as output here. Okay, and that 0 will get initialized to x. And it is not going to increment this k at all because there is a property of this AND operation here. If its left side is producing false, there is no need to go and execute right side, because in order to produce this whole string as true, your left and right both sides should be true. Okay, so what do you think? If this is an OR operation here like this, then what do you think? What should be the output here? Let's compile this and check that. So output is 1 and 9. Why 1 and 9? I'll tell you that. This whole expression is false. Okay, so this is, just first understand, this is an OR operation. This whole thing is OR operation. Just assume this whole thing is written in some if statement. Okay, I'll write this into something if statement. So this is if statement. Now if you are going to evaluate this, how you will evaluate? You will compare this 0 is equal to 1. Is it true? No, it is not true. But OR property is you will go and check this second one also. So second one is nothing but just plus plus. So you are doing increment operation in that, and after this increment the result will be non-zero here. Okay, so I will just move back and make it as it is. So this is going to be non-zero because 8 plus plus will become 9 here. So if it is non-zero here, it means it is true here. If you have watched my previous video, you will understand that 0 is the only case when it is false. Other than that, everything is positive. Okay, positive means true. Okay, even if it is negative value, then also it is true case, because here we are looking for false and true. So in that case, this is true. So once it is true, it will initialize 1 to x, because true means 1, false means 0. Okay, so this whole expression is going to initialize 1 to this x because this whole expression is evaluated as true. This one was evaluated as false. So OR property is it will go and evaluate second portion also, and second portion is evaluated as true and k is incremented. That's why this time you are getting 9 in place of 8, because OR came and incremented it. Okay, I think I made my point. I'm repeatedly telling the same thing again and again, I guess. So if you have any doubt, please ask. Okay, otherwise move to the next question now. Hey guys, I'm back with another interesting question. I'll count till 5, pause the video and try to understand what is happening here. 1, 2, 3, 4, 5. So I think you have got your answers. So let's go and compile this program. GCC, the program number is 36C. At least no compilation error is there. Enter yes. The answer is yes because this is a ternary operation. Actually it looks like this: expression 1 and expression 2 and expression 3 and semicolon. Yeah, so this is the ternary operation. If your first expression is evaluated as true, you are going to execute this one, and if your first expression is evaluated as false, you are going to execute this one. Okay, that's it. So you are doing something like this: 1 is less than 2. Yes, it is true. So once this is true, as I told, if it is true here, you will go and execute this expression. So that's why it is going to execute this expression only. That's why you got yes here. Okay, so let's move to the next question. I guess we are done here. Hello, welcome back. This question is exactly the same question what you saw in previous one. But here is another thing. I'm initializing the whole expression to some variable x, okay, and I'm printing that x. So just try to understand this, what is happening here. I'll count till 5, pause the video. 1, 2, 3, 4, 5. So I think you have got your answers. So let's look at the answer for now. What is this? 42.c. Answer. At least compile time error is not there. And the answer is yes, 4. So this is the answer. And why it is the answer? If you have watched my previous videos, you would have got the answer correct, just because we know what this printf returns. Printf returns the number of characters it printed successfully. So in this case, 1 is less than 2. No, I'll start from the beginning. What will happen? X is trying to get initialized with something, and that something is this full expression, okay? So expression has to be solved in order to get some value and initialize into this x first, okay? So it will start from here. So 1 is less than 2, yes, it is true, and in ternary operator, if this condition is true, it will go and execute this one. So that's why you get yes here, okay? But why this 4? There is a printf property, it returns number of characters it printed successfully. So in this case, yes became 3, and then this new line character become 4. So total 4 will get returned from here, okay? So that 4 will initialize to this x, and you are printing that x, that's why you are getting this 4, okay? So I think we are done here. We should move to the next question now. If you have any doubt, please ask. Hello friends, this is another MCQ question. I'll count till 5, pause the video and try to understand what is happening here. 1, 2, 3, 4, 5. I think you would have got your answer by now, and you can know only if you know what is this whole string, okay? So I am prepared here. The unsigned integer range is from 0 to this number, okay? You cannot store more than this number into unsigned integer, okay? And what I am trying to store is just incrementing this last with 1. So instead of this 5, I am having this 6 here, and it's trying to store this into this x and printing that x. So if you know what happens if you go out of this, you would have given the correct answer, and which is this 0, okay? And why 0? We'll see that. We'll compile this. It is giving you some warning, and if you run this, answer is 0, okay? So the warning is, it is telling that larger than the available capacity, okay? So what happens when you go out of the limit? So this 295, like 4294967 is the limit. If you will go beyond that, what will happen? Nothing will happen. You will just again get back to 0. So I incremented it by 1, means more than 1, then I reach to 0. If I will make it 7, I will reach to 1 here. So let's make this 7 and try to recompile it. Oh, what happened? Oh, semicolon misses. We'll compile it and we'll run this. So we'll make it 7, we'll recompile it and we'll run. See, this time it is 1 here, okay? So if you will make this 7 here 8, then it will become 2 now. We'll compile and we'll see it is 2 now. So what happens if you reach to the maximum value and you give 1 more to that, you reach to 0, 2 more to that, you will reach to 1, 3 more, you will reach 2. So it is like cyclic, okay? So you keep on giving more values than the last value which is possible to store this into the unsigned integer. You will keep on doing this in cyclic order, okay? So this is what happens internally. You will keep on moving the cyclic way, okay? So that's it. Let's move to the next question now. So this is another question. This is little bit a tricky question, and I want to show that how this whole expression will get open, okay? How this is going to get evaluated. So this is the whole question. I'll count till 5, pause the video and try to understand that. 1, 2, 3, 4, 5. So I think you got the answer. So let's check the answer now. 38. At least no compilation error. Answer is 10. Why? Let's look at that. You might be thinking that it should get evaluated like this, okay? Like x is equal to x multiplied by x plus y. But no, this whole right side string is treated as whole one string, okay? sorry, one expression. So in that case, this x will get multiplied with whole expression here. Okay, so if you will open this multiply is equal to expression, it will look like this. Okay, x is equal to x multiplied by with whole right side expression. Okay, so if you will try to solve this, it is nothing but x is equal to 2 into 2 plus 3. Okay, which is nothing but 5 into 2 10. Okay, that's why you are getting this 10 here. If this is the true expression, you have got 7. Okay, but it evaluated like this. Okay, so now keep this in your mind that it gets evaluated this way, not this way. Okay, so I think we are done here. Let's look at the next question.
Hello friend, this is Rupesh and watching CPP Nerds video series on C++, and in this video we'll be learning this MCQ which is about bit fields. So you might not be knowing, or you might be knowing about bit fields. So if you don't know what is bit field, I will recommend first go and learn about bit field, and the video is ready for you and I have given the link in the description field. So before watching this video, if you don't know what is bit fields, please go ahead and watch that one. And if I forget to give the link, please remind me for that. So for those people who know bit fields, this is the question. This is your node and this is the integer x. You are taking only 5 bits out of this integer, which is of 4 byte. So if you will take the size of your node, what's gonna be? Is it going to be 4, 5, 1, or you cannot take the size of this, so it is a compile time error or it's runtime error? So it's you decide. I'll count till 5, pause the video and try to find the answer for this. 1, 2, 3, 4, 5. I think you have got your answers. So let's compile this. So if I'll build this, it has built successfully, so there is no build error. If I'll run this, the answer is 4. And this is just the message that your program was exited successfully. That's why it is returning 0 code from here. And let's check if I will return 1 here. Is it going to reflect here or not? Yeah, it is reflecting here. See, if I return 1 here, it will come here. Yeah. So this 1 will go to the OS, and OS is responsible for showing me this. So this is not our question. The question was why 4? And if you know the answer, please watch another video. If you don't know, I'll tell you the reason. So the reason for this is you will have something like this, ready like this. So this is your first byte, second byte, third and fourth. And depending on the architecture, it might occupy first 5 bits. So this is your first byte. First byte means 1 byte means total it will have 8 bits. So out of 8 bits, it will occupy only 5 bits and assign that to x. And the rest of the bits will go waste. Yes, you heard that correctly. It will go waste. And it's your decision if you want to use only 5 bit and you want integral type, you can go for short, right? SHORT. This is also one type. So you can write it like short x and 5. And this will occupy only 2 bytes. And you are saying that I will be using 5 out of that. Sorry, 5 bits out of 16 bits. Okay? Because short will give 2 bytes. So it's your decision. You are taking very bigger data and you're using very small amount of that. But there is a reason why we use bigger data, and that reason is you can have so many data members from here to here, but the size will still be 4 if it is not exceeding total 32 bits. I'll show you that how to do that. So in order to achieve that, we can have this like 5 and integer z and 5. But still, if you will take the size of this, let's run this, it is still 4. So it's like this. If you have 5 bits, then it will be 5 bits only. It will be using 5 bits only. Otherwise, if you are using 15, it will use 15 bits. If like this, if you are using, let's suppose 20 bits now, k and 5. So in total you are going to use 20 bits. So here it will use 8, 8 and 8 probably till this end, because this is total 8, 8 and we need only 4 bytes of this one in order to make that 20. So this is the idea. You can use a bigger data member and you can divide that into smaller pieces and you can use that. Okay, I'll show you the actual thing here. Let's suppose you're using only one integer here, character C, and here let's make this character C only. So if this is your bigger data type, so as I already explained in my previous videos about structural padding and packing, that how your structure is constructed. So if you don't know that, I have another video you can watch about that. It's structural padding and packing. So in that I have explained how this will go. So to quickly summarize, here the bigger data type is integer. So in this case, our compiler will create memory of 4 bytes like this. This is 0 byte, 1 byte, 2 byte, and 3rd byte. So total 4 bytes. And your compiler will try to accommodate everything in this byte. But if your compiler won't be able to do that, your compiler will go and create another 4 byte. And remember this, it will always create 4 bytes unless you are packing it. So that is another topic. But here what will happen? You are using this 5 bits out of 32 bits. So it will go like this. So maybe not this one, from here to here. This is total 5 bits because from here to here it is total 8. So this is 5. And after that your character is not a bit fill. It is a simple variable. So it will be taking total 8 bits, means 1 byte. So from there to somewhere here it will take C. Okay, so from here to here it is X, and after that it is C. So as you can see, we ended up using only 4 bytes in this case also. Okay, so we can check that. I'll compile this and we can see that. See, again 4 bytes. And if you still want to cross verify, then we can do one thing. As I said, it will be taking full 4 bytes from here to here. But what if we are using total 24 bits from here to here? So it will be taking from here to here. Okay, so this last byte is left for this one, and still we should be using only 4 bytes. So let's check that. So if I'll compile this, we'll still be using only 4 bytes. But what if I increase this by 1? If I make it 25 now, then what will happen? Now we won't be going from here to here. We will be taking 1 bit extra. Okay, so this total is 32 bit. And I said I need 25. So 32 minus 25 is 7. But for this character to be accommodated in this place only, we need 8 bits, but we are left with 7 bit. So your compiler will again create full another 4 bytes because your bigger data type is of integer type and it takes 4 bytes. Okay, so compiler will create that and compiler will place your new character, this character here. Okay, so let's check that, and this is gonna be fun. See, if I'll make this, it's 8 now. So I think you would have got the point how this whole thing work. Okay, and I think we're done here. Wait a minute. As I said, here in this case we were using this C as a full character, so it was taking 1 byte, and that's why we ended up losing this 7 bytes, 7 bits here, and we created another 4 bytes. Okay, so what if you are using only 7 here? Because we are left with only 7, and what you need that much, then it will be 4 only. Let's compile and check that. See, it is 4 only. So as you can see here, it gives so much of optimization, and it will really help a lot to those people who really care about the memories and all, because they are working in the embedded systems and they really don't have much memories to use. Okay, so I think I'm pretty much done here. Thanks for watching, and don't forget to hit the like button for this video if you think it deserves that. and make sure you subscribe to my channel if you haven't already, because I'll be uploading videos like this pretty much every day. Okay, so thanks for watching. Bye bye. I'll see you in the next video.
Hello friends, this is another question. This is exactly the same question as the previous one, just I have changed this multiplication instead of division operator. Okay, so I'll pause, I will count till 5, pause the video and try to understand what is happening here. I know you will solve this problem. 1 2 3 4 5. So let's look at the answer for this. GCC 39. No compile error, and the answer is 2. Why? Because this whole expression is going to get evaluated in this form, right? Not in this form. Okay, we already saw in the previous video. So here 2 divided by 2. So first this will get evaluated. So here 2 divided by 2 is 1. So this whole thing will look like this now. 2 divided by 1. Okay, so it is nothing but 2 divided by 1, which is 2. That's why this answer is 2. Okay, so if you have any question, please ask. Otherwise, move to the next question now. Friends, this is another question and you need to focus here first. Okay, so I'll count till 5, pause the video and try to understand that. 1 2 3 4 5. I think you got the answer, and this is not a tricky question. This is really very easy question. So let's go ahead and just compile this. 40.c. Answer is 0. Yes, it is the expected answer, just because what is happening here? You are doing something like this. X is equal to X and Y. Okay, so X is 1, Y is 0. So Y and operation with 0, which is 1 and operation with 0, is always 0. So you are initializing 0 here and you are printing that. Okay, so no tough thing here. So if no tough thing, let's look at the next video. Maybe you will get something there. Oh my god, what is this? Is it going to compile? We'll see that. I'm going to count till 5. Understand this question and pause the video. 1 2 3 4 5. I think you have got your answer. So let's compile this. This one is 41 and answer is 1. Successfully compiled. So we'll see what is happening here. You are doing A is equal to B plus C. Okay, so A is 10 and B is 5 and C is 5. So this whole thing is looking like this. D is equal to A is equal to actually 5 plus 5, and instead of this A we will write this 10. So this is looking like this. So this 10 is equal to 5 plus 5. Yes, because this 5 plus 5 is also 10 only. Okay, so 10 is equal to 10. Yes, so that's why it is returned 1. So 1 will come here and that 1 will get assigned to this D here. Okay, and why 1? Because this whole expression was evaluated as true. If you have watched my previous video, you will get to know why 1, why not 0. Okay, and if you want to see some 0 here, just change a little bit here. I will do something here. Okay, so now it is not going to be equal with this one and D is going to print 0 here. We will see that in a moment. See, it is 0 now. So this is evaluated as 10 is equal to 11. Is it true? No, this is not true. So if it is not true, that's why it is returning 0 in place of this whole expression, and that 0 is going inside D. Okay, and you are printing the D, that's why you are printing 0. Okay, so I think we are clear here. If you have any doubt, please ask in the comment section. Let's move to the next question now.
Hello guys, this is another CMCQ question. So pause the video and think about it. I think you will have got your answers. So let's check this out. This is GCC 41.c. There is no compilation error. If we will run this, the answer is, oh my god, this is an infinite loop. You can see that. Okay, so I'm gonna press Ctrl C to pause it. So the answer for this is D, infinite loop. Why D? Let's check this out. Initially the number is 7. We are telling that
the number is not equal to 0 and number minus minus. Here we are going to print number post decrement. Okay, so number will be 7 when it will print first time. 7 is printed, number is decremented by 1. Here again it will get decremented by 1. So here it will become 6 and then here it will become 5. 5 is not equal to 0, no problem. 5 will get printed, it will get decremented by 1, so 4. Here again it will get decremented by 1, so 3. 3 is not equal to 0. 3 will get printed, minus 1, it will become 2. Here it will become 1. 1 is not equal to 0. Yeah, that's fine. Here it will print 1. Then again decremented by 1, which will make it 0 here. But again here it will get decremented, which will make it minus 1. So minus 1 is not equal to 0. Yet is true. And now it is not going to reach to this 0 ever. Okay. Or maybe in some cycle it will reach to 0. I'm not sure about that. But you can consider that as infinite loop. As it is not compile time error, not run time error. And obviously this is not 7531. Okay, so the only option you are left with is infinite loop. Okay, so let's look at the next question now. Hello there, this is your next question, and in this question is about this macros. So let's give it a try. I think you got your answers, so let's check this out. This is GCC, this is 42.c, there's no compilation error, and the answer is CPP percentage S and nuts. So this is your answer. If you don't know why it's like that, let's understand this. So we all know what this hash define does. This is nothing but a macro here, and in compile time this scanf will get replaced with this particular string here. Okay, so if you replace this string here and here, you will automatically understand this. So if this is here, in that case this is like CPP and it's percentage S. So whatever is there in this side after this comma will be treated as a string. Okay, a single string. So that's why it is printing CPP. After that, because of this percentage S which is here, it is taking this whole string and pushing here. After that nuts is coming. That's why the answer is this one. Okay, I don't think there is any problem to understand this question if you know how this printf and this macro things work. Okay, so let's look at the next question now. So this is your another question, and in this question we will be learning about this right shift operator. So if you know how this right shift operator, you might be able to crack this. Okay, so let's give it a try now. I think you will have got your answers, so let's compile and run this. 43, and there is no compilation error, I know that, and the answer for that is 1. So the answer is G here. So let's understand why it is G. So we all know this is a do while loop here, from here to here. So do while loop is a exit control loop, so we will control the loop in exit side, not the entry side. Okay, so if we will see the bit pattern of this I is of integer type. So integer have 32 bit in my system, so it will be like 0 0 0 and 0 and then 1 0. Okay, so there will be total 30 zeros, and then these 2 bit will be like 1 and 0. So 1 0 means 2. So if you will right shift this one, so for simplicity you forget this, let's assume you are having only 1 and 0. If you will right shift it one time, so we know that okay, if you will right shift this thing, this 1 will come to this place and this 0 will get discarded. Okay, so let's suppose this is like this is filled with 1 and this is filled with 0. So 1 will come here, so 1 will come here, and here it will become 0, and this 0 what it was holding will go out and it will go discarded. Okay, so the bit pattern you are left with is 0 1. So initially it was 0 from here to here, now it is 30 zeros and then 0 and 1. So it represents 1 in decimal. Okay, so coming back to the point here, if 1 and then break, then we can say that yes, this is going to get true and it will come inside, and you are breaking the loop here. So that's why you're coming out of this loop. That's why you just end up printing this I one time. Okay, I think we're done here. Let's look at the next question now.
Hello friend, this is Rupesh and I'm watching CPP Nerds video series on C MCQ questions, and in this video we'll be learning about bit fields MCQ. Okay, and if you don't know what is bit fields, I have given the link in the description field. Go ahead and watch that video. This is very important when it comes to the interview questions or in exams or anything. Okay, so let's get into this question. The question is, you are creating this node n, and inside this we have this x as bit field, and we are taking it as 3. I mean, we are taking the 3 bits out of 32 bits. Okay, and we have assigned 2 inside that x, which is okay, and we have taken the address of that x, which is of type bit fields, and assign into integer pointer, and then we're just printing that pointer and printing that n.x. So it should be okay, wait a minute, this should be n, and the answer should be 2 2 or 0 0. Okay, so I messed up with these options. So what do you think? What should be the answer? Is it going to print 2 2, compile time error, 0 0, or runtime error? This is going to be a very small video, but it will give you a very good understanding of one point related to the bit fields. So I'll pause the video, try to understand the question on count of 5. 1 2 3 4 5. I think you would have come up with the answers. So let's run this. So, but before that, let's compile this. So it is saying that bit failed. Bit failed means it is not compiling. So address of bit field requested. So at this line we have the error. It is saying that you cannot take the address of bit field. This x is of type bit field. So let's just confirm that if we have some another y inside this and we want to take the address of y. So is it going to work here? Let's see that. So in order to check that, we should assign y also with, let's say, another number 3. So let's compile this. Build successful. If you will run this, programming saying 2 and 3, it means it is working. Okay, so 2 is for this one and 3 is for this one. So we understood that we cannot take the address of bit fields. So this is one good point to remember that, and I have explained this point in that video and along with other points as well. So it's better to cover that video. I'll see you in the next videos. Bye bye.
Hello friends, this is another question, and this question is a recursive question if it is allowed with the main. Okay, so find out the answer for this. I think you might have got answers, so let's run this. There is no compilation error. So if we run this, 5 4 3 2 1. So the answer is this one, D. And why it's so? If you know the answer, please move to the next video. Otherwise, stay with me. I'll explain that. So here we can see that we have this variable x being initialized with 5 here for the first time you entered inside this main, and we are printing post decrement operator. So we know how this post decrement operator work. First, it will print the value whatever is there inside x, and then it will decrement the value of x. So first time it will end up printing 5, and then it will decrement it. So x was initially 5, now it has become 4. Will come down if x, yes, x is not 0, so it's true, it will call main. So you will again end up calling yourself. Next time you will come inside and you will see x is being initialized with 5. No, this is not true. If this is static variable gets created only one time. Okay, so the creation part is over. So this line is not getting executed second time or third time. It is just going to get executed only first time whenever this function will get executed. Okay, so in that case x will have its old value. Old value is 4. So we'll end up printing 4 here. We'll come back. 4 is not a 0. So we'll again call main. So we'll again go back and reach to this line. But this line is not getting executed. Print 3 because when we executed this, I forgot to write 3 here. So this time 3 like that 4, 2, 1. And when we'll print 1 here, this x will get 0. Okay, don't miss that part. Like this, and this will become 0 here. Once it will get 0, it will come to this place and we'll see, okay, yeah, this is a 0, so it is not going to get executed. Then it will come to this point. So once this is hitting this and curly braces, it will go return back. Okay, so it is like first time main was called M1, M2, M3, M4, M5. But because of M5, this X was converted to 0. So M5 was returned. So M5 will return to M4. So in that case, M4 was like when the value of X was 1, we end up calling main that time. So we reach to this place again. Okay, so now we are coming back from that place and we are going to encounter this curly braces for M4 also. Okay, so we'll go back from here as well. So the same for this one and this one. So like this we will come back and this whole program will terminate. Okay, so if you don't know about the recursion, you might find this problem little tricky. So I better suggest go and learn about the recursion before commenting this video. Okay, so I think I'm done here. Let's look at the next question now. And yeah, I wanted to tell that this static variable is very important thing here, because if this static won't be here, main will call again itself and this integer x is going to be 5 again and again and again. It is never gonna get to 0. So this will be like an infinite loop and you are not going to get out from this loop. Okay, so this static is very important here. So let's look at the next question now. So this is your next question. This is fairly simple question, but sometimes people might get confused, so I included this as well. There is nothing special in this function. It is just a main function and we are just keeping this main here. So what is the meaning of this printf here? Okay, is it a main address, or it is a compile time error, runtime error, or it will print some garbage value? Okay, so this is GCC 46. There is no compilation error, and if you will run that, the answer would be some address. So this is nothing but the main address. We know all the functions in C and C++ have the addresses. So this main has its own address. So by writing main like this, you are just telling that I need the address of main. Okay, so this was very simple. Let's look at the next question now. So this is your another question, and don't miss this comment line here. It says that 32-bit processor is used in this compilation. Okay, so find the size of integer and integer pointer and integer double pointer. I think you would have got your answers by now, so let's check this out. GCC, this one is 48, I guess. There's no compilation error. If you will run this, the answer is 4, 4, and 4. So D is the answer here, and let's see why. We all know how to know the size of integer here. Before it was 2 byte, now it is 4 byte. But what about this integer pointer and integer double pointer? Actually, if you want to know the size of your pointer, just find out what processor you are using. If it is 32-bit processor, then divide this 32 by 8. So the answer will be the size of your pointer. Okay, and if this would have been a 64-bit processor, in that case this would have been the answer here. Okay, 4, 8, and 8. So we are clear here. Let's look at the next question.
Hello guys, this is Rupesh and I'm watching CPP Nuts video series on MCQ question, and this video is about designated initialization. So you might have noticed this, that I'm doing something weird in this array here. So if you have watched my previous video, maybe you would be able to understand this and you'll give the correct answer for this. Pause the video and try to understand what is happening here. 1, 2, 3, 4, 5. I think you will have come up with the answers. So let's compile this. So GCC 49. There is no compilation error. If you run this, the answer is 20, 10 and 0. So B is the answer. And why B is the answer? Because you are initializing these values to the designated positions here. So at first location you are initializing 10, and 0th location you are initializing 20, and second location you didn't initialize anything, that's why you end up getting 0 here. Okay, so this is how it works. So if you want to know more about designated initialization, you will get the link in the description field. I have a full video about that. Thanks for watching. I'll see you in the next video. Bye bye.
So this is your another question, and this question is little tricky for those people who know that if you are not keeping break here after every case, then what problem could come. Okay, so please check this program and tell me the answer. I think you would have got your answers by now, so let's compile this. This is GCC 55 and there is no compilation error. Generally my program doesn't have compilation error. Yeah, so the answer is 11, 16 and 21. So the answer is 11, 16 and 21. So that A is the answer here. But why A is the answer? If you know, please move to the next video, otherwise stay here. So we'll start from the beginning here. We can see I is equal to 0, and in this for loop we are again initializing it with 0, and we will check I is less than 20. Yes, so 0 will be checked here. So here this case will be true. So you will enter here inside this. So I will get incremented by 2. So I will be 2 now. Before it was 0, now it is true. But you will not come out from this switch because you have not written break in this case. So what will happen is you will keep on executing till you hit the break. I mean the first break. Okay, from where you entered. See, this is your entry point. If you have crossed this entry point and you have entered inside this, then you must have break in order to come out from this switch. Otherwise what will happen, it will come from here to here and this will get executed. So I will become 2 here, then plus 1 it will become 3, then here plus 8 it will become 11. So after that it is hitting the break here. So we are coming out of this switch and we are printing the value of I, that's why it is printing 11. Okay, so this is your end of the loop. So you will go back, you will increment it by 1. So I will become 12 now. Now you will come inside and you are checking that is case, I mean I is 0, 1 or 5. No, it is 12 now. So you will not go any of the case. So you will go to default case and you will add it by 4. So I will become 14. And this is the last statement of this switch. You will come out and you will end up printing 14. So it is 14 here. Okay, then you will again go back. I will get incremented by 1, so it will become 15 here, and then it will check, okay, I is less than 20. Yes, it is true. So it will come again. Oh well, I did this mistake, right? Yeah, I know you guys might be shouting in the video. I can understand that. So after adding this will become 16. So it will go 16 here. Sorry for that. And then it will get incremented by 1. So it will be 17 after this last I++. And 17 is less than 20. So it will come inside again. And case is 0, 1 and 5. But it is 17. So it is not going to insert either of the cases. And it will increment I by 4, which will become 21, and lastly we are printing 21. So this is our answer. Hello there, this is your another question, and this question is very simple question. You're just creating a simple structure here and you're just printing that. So let's compile and check whether it is working or not. So this is GCC and the question number is 67. So, oh my god, this compilation error. Oh, I didn't give the options also. Okay, don't worry. The point here is, in structure, you define a data type, not initialize the data. Okay, it's just a simple type here. You are declaring a type, not the data. Okay, so in C particularly it is not allowed. So if you will remove this initialization part here, this would work. So let's just simply remove this. We need to give some value here and we're done. Okay, so if we'll compile this now, it should compile. Yeah, see, it compiled. If you will run this, you may get some value. And this is nothing but a garbage value because we didn't initialize it outside. Okay, so the point was, in C structure, you cannot initialize your data members like this. Okay, so let's look at the next question now. So here is your another question. Try to think about the answer for this. I think you might have got your answers, so let's compile this. So there is some compilation warning. There is no error. Actually, I have extra warnings here. So let's run this. Answer is x is equal to 10, x is equal to 0. So the answer would be D here. And why D? Let's look at that. First of all, you will come inside main. You are going to print this x. Definitely you will be getting this x only. Because if you remember my previous video, I said that whenever you reference, the use of the variable is referenced first inside its own scope. So x will be this one. Okay. Now this is just a function call here. So you came here. Now you're printing x. In that case, this x would be this global x. Okay, not this local x. So this x belong to this area. You cannot get in this area. Okay, because the scope is different. And yeah, you understood correctly. Let's suppose you are having some another variable here. Let's say y. Okay, and you want to access that y here, then you won't be able to do that. Okay, you want to print whatever the value is there in y, and you will have compilation error. So it is telling that undeclared y in this case. So if you want to use y here without having y as a global variable, you have to have this in your local space like this. Then you can use that. See, there is no problem. I'll show you that. See, this is just a simple warning. It is telling that instead of printf x, you wanted to use printf. No, I don't want to use that. My compiler is being extra smart with me, but I like that sometimes. So we're pretty clear here. Let's look at the next question now. So this is another question. This will be a little interesting if you don't know one main thing about the pointer here. So compile this in your mind and tell me the answer. I think you would have got your answers by now. So let's compile this. So the question is GCC 76 and there is no compilation error. And if we run this, you will see segmentation fault and we will see why this segmentation fault is there. So here simply you are creating an integer pointer and passing that pointer to this function. Here taking that and allocating the size of integer to that memory, right? You might be thinking like that, but it is not actually the way you are thinking. It is something like this. So you created a pointer here, you pass that pointer to this function, you reach to this place. After that you're initializing dynamically created memory to that pointer, right? You might be thinking that way, but it is not like that. I'll tell you how it works. Let's suppose you created this integer pointer, right? So let's make it like this. And whenever you will create it like integer pointer p, it will be like this. 1, 2, 3. Let's suppose this is the address of that integer pointer and it holds something like 2, 3, 3, 4. Okay, and this is your p here. Okay, I'm in the pointer p. Now what you're doing by passing this p is you're passing this 3, 3, 4. Okay, you're getting that 3, 3, 4 here in some another pointer.
So let's create that as well. So if you'll create this integer pointer a here, let's give some address to that, and this 334 will come here. Okay, and this line here tells to the compiler that I will be creating a dynamic memory of size integer, and that would return a void pointer from here. That void pointer will get converted to integer pointer, and that memory will get assigned to A. Okay, so let's see how it is working. So you had this 334, some garbage when you created this integer pointer. So this is the address of the pointer, and this is a value part. Okay, so this is value. This is again a value of integer pointer A, and this is again the address. Okay, now by this you just replaced this with some number. Let's suppose this malloc is returning some another number, 552. Once this 552 is initialized, you are coming back from here. So in that case, you are coming to this place now, and after coming back, you're trying to change this p reference is equal to 0. What it means? It means dereference 334 and initialize 6 inside that. So this will go to this memory address, and you are going to assign 6 to that memory address. But the problem is, maybe this memory is not under your process. So that's why segmentation fault has come. Or this memory is already in use or something. But the only part is you're not allowed to use this memory. And did you notice your dynamically created memory is lost? You don't have any access to that now. Okay? So that's the reason we got this runtime error here. Okay? So to overcome this problem, we don't send this P like this. We send the address of the P. Okay? This portion, 1, 2, 3. Okay? You will get this 1, 2, 3 and double pointer A here. Okay? So this won't be a single pointer. This will be a double pointer. And then you will construct that memory. That memory will get constructed easily. So let's try to figure out that as well. And let's suppose 222 is the address of double pointer A here. Okay, and it is holding some value like 333 when it got constructed. But when you replace that value with this P address, which is nothing but 1, 2, 3, so this will go and 1, 2, 3 will come. 1, 2, and 3. And this instruction here will look like this. Some pointer will come here. Okay, so pointer means A is this one, 1, 2, 3. Now you are dereferencing that. That means you are dereferencing that memory area, 1, 2, 3. That means you are pointing at this location right now. Okay, because you are dereferencing 1, 2, 3, right? And 1, 2, 3 is this one. So whenever you will initialize some address, now that address, let's suppose this one malloc was returning 555. So now this time what you're doing, dereference 1, 2, 3 and initialize this 555 with conversion with this integer pointer 552. 552 was there, right? So this malloc is returning this address, converting that address into integer pointer and initializing whole into the 1, 2, 3 dereferencing place. So if you will dereference 1, 2, 3, it will reach this location. So you end up assigning this 552 to this location here. Okay, now 552. Now 5, 5 and 2. Here 552 will be there. So did you notice you successfully assigned a dynamically created memory in your pointer in some another function? Okay, so let's see the example what I told. Does it really work or not? So what I said, if you will not send this function without this pointer, so we are sending the address of P, we'll take this as double pointer because it is containing the address of pointer, so it should be a double pointer. Now we are done. If you will compile this now, let's compile this, there won't be any error, and if we'll run this, the answer would be 6. Yippee! Okay, so I think we are clear here. If you still have any doubt, please comment. I'll be very happy. And if you like this video, please don't forget to hit the like and subscribe button, and you can comment how did you felt about this video. I'll see you in the next video. Hello there, this is another question, and if you have followed my previous video, you would be able to understand this very well. That what should be the output of this one, either 1, 2 or 3. Okay, so I didn't give the options here because it is very trivial. If you are following my all videos, you will be getting the answer very quickly, either 1, 2 or 3. And let me tell you, the answer is 3 here, because this one statement, I mean one expression here, like 1, 2, 3 is one expression because it is covered with this bracket here, so it becomes one expression. So the result of this expression is going to this variable. Okay, so that's why 3 is going, because the comma operator worked like this. First it will execute this one, then this one, and then lastly this one, and whatever the result is will be assigned to this one. So lastly we are executing this one, so our result is whatever is the output of this one. So 3 is being assigned to this variable, and we're just simply printing that. Let's quickly see that. So this is 89, I guess, if I'm right. Yeah, variable 3. Okay, if you just saw the previous video of this video, you'll be able to understand that. Okay, so let's look at the next question now, guys. So this is your another question. Assume here that your processor is a 32-bit processor, and give me the answer for this. I think you would have got your answer, so let's compile this. This is GCC 81. There's no compilation error, and if we'll run this, the answer is 4, 4 and 4. Why it's 4, 4 and 4? Because we are printing the pointers here. Okay, I mean the size of the pointers, not the normal variables here. Okay, so remember your pointers are always 4 bytes in 32-bit processor and 8 bytes in 64. Okay, actually pointer means it will be holding the address. Okay, and what is the size of your address register or the accumulator register, I can say, is 32-bit here. Okay, so your computer can process 32-bit at a time. It means this is the address space it can handle. Okay, if it is 64, it can access 64-bit address at a time. Okay, so as size of give the number of bytes here, we are getting 4 bytes, 4 bytes and 4 bytes. Okay, so the answer is D here. I think we are clear. Let's look at the next question now. So this is your next question. You might be familiar with this type of questions because I have already given these type of questions before in my MCQ series, but let's see if you recall this. So tell me the answer of this question. I think you might have got your answers. Let's compile this. This is a compilation error, and the answer is 20. Why 20? Because why not 40? You might be thinking that 20 will be processed, then 30 will get processed, then 40. No, it is not like that. Here in this case, this is just a simple statement, one statement from here to here, comma, another statement 30, another statement 40. Okay, so they are executing as a statement. So this statement is you're initializing 20 in variable. Okay, this 30 is nothing but a 30, it's a constant, nothing is happening here, and 40 the same thing. Okay, so 20 was assigned, then 30 was just simply compiled. There was no significance of 30 and 40 in our program here. Okay, but let's suppose you want to change the behavior, you want this 40 here, so in that case you will have to use this braces. Now 40 will be the answer. Let's see. The answer is 40 now. Why? Because now this whole thing is a one expression now. By grouping this with this bracket here, you're saying that this whole thing is one expression, and the result of this one expression will go inside variable. It's that simple, guys. Okay, so let's compile this. Like 20 will be executed, or 30 will be executed, and in the last 40 is there. So whatever the result of 40 is will go inside variable. Okay, So that's how this thing will work. Why I'm telling 20 will execute and 30 will execute is just because if you will do something like this, here we can use that concept, you will print 2. That's it. Now let's see what is the answer for this. Okay. If you will compile this, there's no problem. If you run this, the answer is 1, 2, 3 and VAR is equal to 1. So let's compile this line by line here. What is happening here? Printf 1, printf 2, printf 3. So this is the sequence how this comma operator will work inside this bracket. I gave you this example so that you can think of like how the evaluation goes inside this bracket. Okay, so see, 1 is printed, 2 is printed and 3 is printed, and your VAR is initialized with this printf. And what do I mean by initialized? If you recall my previous video, what is the return of printf? It's nothing but how many values it printed. And why 3 is resulting as 1 here? It's just because this is just a simple one character. If you will make it like this, like CPP nuts, how many characters are there? 6 characters. So if you compile this again, you'll find that it is initialized with 7. Oh my god, it is total 7 characters, right? Oh, so sorry for that. So our main point was how these things will execute line by line. Okay, so this is the sequence for that. I think you got this. So let's look at the next question now. So here is another question, and this question is related to this comment lying in this statement here. So it's like you're initializing C with A plus B, but in between that you got this comment here. So is it going to work like this? I mean, is it a compile time error or a runtime error, or it will produce any of these numbers? What? Think about it. So let's compile this. This is 90. There's a compilation error, and if you'll run this, the answer is 30. Yoo-hoo! So that means life is beautiful has no meaning here. Okay, actually it has very big meaning, but here in this line, when compiler will compile this, before even starting the compilation, if you recall your basic classes, it was told that your comments are removed from your program. They don't have any significance for the compiler to compile your program. So in that case, this whole thing will be removed before even starting your program compilation. Okay, that's why there is no error in this. Gotcha? So let's look at the next question.